Hi guys, earlier in this quest, we learned about power generation. We studied generators and how they work by converting mechanical energy to electrical energy by inducing a current in a coil. But most times electricity is not consumed at the same place it is produced, and therefore it has to be transmitted from the power plant to the final user. So in this lesson, we'll learn about power transmission. Electric power is the product of current I and voltage V, given by the equation P is equal to IV. So the same power can be gotten either by combining a low current with a high voltage or by combining a low voltage with a high current. So let us say we have an electric power plant with power at 720 kilowatts and the average resistance of the transmission wires is 30 ohms. Now, using a low voltage of 480 volts, what would be the current and the power loss? The current will be power divided by voltage. So 720,000 divided by 480 is 1,500 amps. The total heat loss is given by H is equal to I squared times R, which is equal to 1,500 squared times 30, which is 67.5 megawatts. And this is almost 100 times the generated power being wasted on heat. Not ideal. Now let us try a high voltage and low current scenario. If we switch the voltage to 60,000 volts, what would be our current? Now dividing our generated power by the new voltage, we'll have 720,000 watts divided by 60,000 volts. And how much would the heat loss be in this case? 12 squared times 30 is equal to 4,320 watts. This is 0.0006% of the generated power. Now, if that is not enough reason, high currents need thicker cables. So transmitting in this way will cost a lot of money, which adds to our electricity bill. And no one wants that. So what power plants do is, before transmission, they lower the current and raise the voltage using what is known as a transformer. Transmission at high voltage is what is known as high tension transmission. Now on the other end, another transformer now switches this power to a lower voltage and a higher current before finally allowing it to reach our homes. I bet you have heard of or seen transformers before. The ones in your neighborhood look a bit like this. And in the next lessons, we'll learn about how they work. See you there.